See, there's an image of the atomic spectrum of the sample I just looked at.
Okay, perfect. All right, so we're in Edmund Storms' private lab. We're going to be looking at some samples in a EDM, his SEM, and we're extremely privileged. So there you go, Chuck. And we're going to learn something. So
now we have to worry about size.
right.
And take a piece off.
We'll go over the building and all that stuff and how I got to where these are at a little later. But they should all be relatively the same. And where I'm at right now with this particular metal is this started from salt water. Okay? Electrolyzed out through the platform that I was telling you about, the near prism and the hydrogen circuit. The electrode, this is not electrode erosion. We've grown 4-inch electrodes that weigh 5-6 ounces, maybe at the tops, right? They weigh more now than when we started, and I pulled 35 pounds of stuff, off of these electrodes, precipitation. And I've noticed that if I change the frequencies, I can get different metals and different stuff. I've made whole gold, a lot of it. I pulled other metals.
Well, let me stop you just for a second. Let's put it in because it's going to take a little while to pump down, and you can explain this while that's happening.
And so, this where I'm at right now, the reason I left these in bar shape is because, for some reason, because I'm trying a new process. Once you, this one might be mostly metal. Here. Once you get them, it has a deterioration factor. Yeah, very interesting. When it hits oxygen, it holds its color for a while, then it changes super quick. These bars are extremely hard. I'm a little surprised.
That I can put in.
Okay. It's going to have, well, hold on, before you put that in, let me get the metal out of the middle of it.
You say there's metal in the middle of it, David?
Yeah, there's little beads in the middle.
Now, will that microscope radiate through to the metal in the middle of it, or do you have to extract the metal?
It's going to look at whatever's in the position of the beam.
Okay, so let me see.
The scanning electron microscope bombards the
Get a
sample with
hammer and-
electrons.
This one is hard as a rock. It might be,
And these electrons then
oh goodness.
Well, get a hammer.
reflected back and they're
This is-
collected.
So you're going to get the surface reading, not what's in the middle of it.
Right.
Okay.
And then the electrons stimulate X-rays that are characteristic of each element that's present. This thing picks up these X-rays and it displays them over here as a spectrum, and the machine then identifies which element they came from. Again, that's only the surface. A few microns of the surface is all that this can look at.
Okay, well, we're working on that. I just realized, see, these were brittle when I first took them out, but now I can't break them. This has been about 2 weeks now. And what I've noticed from biological metals is the theory is they go through a radioactive stage. And if you fight the radioactive stage with radioactivity, like fire or heat or something, or even a microwave, you can combat that half-life. And once you combat that half-life, you got it. But if you don't, it'll just dissipate. These ones, I specifically heated them about 24 hours. And then I poured these out, and before, like I said, they're brittle, but you feel that.
It's very dense.
Yeah. And when it came out of the, when we poured it out, it poured out wet. And when it cooled, it was wet, like it was sweaty, right? And this was like a day or two later, and then eventually the crystalline structure that you're looking on the outside is what we should be studying. Because what that is, I have no idea. What I think it is, I have an idea.
Well, this is corrosion. I mean, it is typical corrosion, so it's probably an oxide of some sort.
Yeah, we don't even know what kind of oxide.
Well, I can tell you. What it is.
That's exactly why I'm
Yeah.
here, is to look at this.
I mean, most oxides are white, and so you have no white corrosion characteristic here.
And this
As
one,
far as radioactivity goes, we can determine whether these are radioactivity very simply.
okay.
Now, this has got a lot of water in it. It's taking a while to pump down. So
Now this one, I had a cracked crucible, and this one fell into the bottom of the crucible, fell into the catch, safety catch basin. And so this one has a lot of metal in it. What the metal is, I don't know.
What is it that you start out with to get this, David?
Salt water. Just straight salt water. This is only about a quart of salt water. This is not the precipitation of the metal from the salt water. This is literally growing biological metals.
And is-
well, I mean, you're testing my ability to understand this because it makes absolutely no sense. I mean, we know that conservation of mass is a very fundamental idea in chemistry and physics. It's not something you can.
I'm
Yeah.
treading so lightly because I know this is why you would be like one of the only people that I could sit down with. You would mess around with Olive Fusion, you work with Los Alamos. I respect your entire history, trust me, and I'm being very light on my claims with you, but I think that you'll see here shortly that this is something worth looking into. To me, I don't really care what metal it is. I just care that this metal was not there when I started. It is not electrode erosion, and I can make a lot of it in different spectrums. One of the metals, one of the samples that we need to look at is this one. Okay. It's metallic.
Well, it's been melted.
It's conductive. You cannot give it a radio, you cannot give it a magnetic signature. A good friend of mine, Art Devine, who's the man who invented the magnetic recording head that got us from a megabyte to a gigabyte, right? This guy is like the king of electronic magnetism. We tried with 3 times the power how you magnetize neodymium magnet. Could not get stick. It's got zero
now,
Gauss.
let's back up. I mean,
And hold on, I'm not done. I can take this piece of metal and I can walk through any radar detector, any metal detector, and I do it for the humor of it. When I go like into the courthouse or on a plane here, undetectable.
yeah, I mean, a lot of materials are undetectable. This is what looks like typical slag that comes from
It's
the smelting of various metals.
Right.
And it's not a metal, it's actually an oxide, a combination of oxides that have melted. And so, of course, it has no metallic characteristics because it's not a metal. This is a compound.
It has a conductivity to it.
Many compounds are conductive. You don't have to be a metal to be conductive. Metal is defined by certain characteristics. It needs to be conductive, yes, but lots of other things are conductive and they're not called metals. But it has other properties. You know, it's shiny, it's ductile. I mean, this is not shiny. This is not ductile. This is a piece of molten oxide, a compound.
It has interesting characteristics because, I can electrolyze it. I can.
No, that's probably right because it's too stable. These are generally oxides of iron. That's why the color. whole different metals form these oxides and then leave as slag. And you can have all kinds of junk in there, but it's basically an oxide that's been molten. But it looks just typical of a slag.
Right, I do a lot of welding and stuff like that and other things, and these particular precipitants, what we call them, because
We have a problem here. I can't get a vacuum on it. There's too much water in there.
I probably assume that.
So let me get something we can break off a piece
Okay.
and which we can then.
You
put
have a pair of
small piece in
pliers?
there.
Because I'd like to break this one open.
Yeah, okay, let me get some tools and we can do that. And bend this down.
I have nothing on me. This is. How much magnification does this one have?
You can see down to about fraction of a micron.
Okay.
Yeah, this is slag type also.
Well, there's going to be some borax in there as the flux and the binder, and there's going to be some.
Yeah,
Mostly
there's
borax.
actually three components here. There's this right here, which is something that has molten, it's probably an oxide. There looks like a bit of something that might be a metal here, and then there's a different kind of compound that's
Mhm.
starting to fall apart.
Interesting. Yeah, I'm looking for the top versus the bottom, and that's if we break it open, we can get one of the beads out, one of the buttons,
Yeah.
either in this one or this one, and then we can study just the button because the rest of it's going to be borax. I'm not worried about that.
Yeah. Okay. It looks like this was made by heating something at a fairly high temperature.
Oh, correct.
Yeah.
Very much.
Okay. Let me see if I can get some tools that we can use. Hang on.
This is great.
So when you are doing your thing with the water, is that the algae form that's cooked down?
At different frequencies will give different results.
So
I think
the
I'm gonna-
composition here is just of the same water, it's a different frequency of the water
Correct.
that gets you
Different elements.
a different outcome.
Yeah,
of element.
Yeah, that's the best word, a different outcome, because like this one here, that's metal, or that's a
So that one possibly slag, that one possibly
yeah,
monoatomic
yeah,
G,
I wouldn't,
and that one may be,
see this one here. I've had a couple people look at this
what did
one.
we say the other day, ruthenium?
This one is slag, thinking it's slag, but you see that? See those round balls there?
Right,
Those round balls are not slag. You should test this one from this way, looking this way, not this way, looking this way, because this is the bottom of the pore, and he needs to check what these
Right.
different ones are, and then we would know.
now did we say this was ruthenium?
I have no
Possibly.
nothing, but this one is going to be interesting.
Okay,
Listen, these were brittle when I first took them out. I mean, they were.
you could crack them with your hand.
Oh yeah, this one you just broke with your hand, but now that they've cooled, they are solid.
That's amazing.
It's
And we're talking about in a bioform, microbiology form of a plant life, and this is
the result.
the result.
See how that carves away? If I can get a button out of this one.
Well, smash them up.
Well, that's what I tried to do, but they don't
Go
want to.
take them out, find a rock, and smash them up, and let's bring back the sand.
He's gonna get some tools.
All right, I'm gonna cut out here till he comes back.